Dear students, under the lecture series on graph theory, here we have lecture 7. In our previous video, we saw problem 1 and now we are going to learn problem 2. Show that in any group of 2 or more people, there are always 2 with exactly the same number of friends inside the group. Now, in order to understand this problem better, let us represent this problem in the form of graph. How are we going to represent it as a graph? Now, in any group, so this group of people, we are going to consider as a graph G. So, first let us write that. So, let us represent the group of people as a graph. How are we going to represent them as a graph? Each people we are going to take as vertices. So in this graph G, okay, so this graph is G. Let the vertices, that is each people, is represented as V of G and they are named as V1. So V1 represents one person, V2 represents another person. So like that, we can consider some known people as there are P number of peoples, so VP. So these are represented as vertices. And what will be the edge? Edge will represent that those two people are friends. That is, it will show the relationship between the people who are friends to one another. So, an edge between two vertices represents that those two people are friends. So, the edge, if they have a friendship, it is represented as an edge. Now, if it is so, then what will be degree of a vertex? So, then degree of vertex. So, if we take a vertex V, what will be the degree of a vertex? It is the number of edges incident with the vertex V gives the degree of V. So the number of edges, what it represents? Friends. So the number of friends of this vertex V will be the degree of V. So the degree of V will be equal to number of friends of V. And now what we have to prove in this problem? We have to prove that there are always two with exactly same number of friends. That is, there are always two people with exactly same number of friends. For this, since we have represented it as a graph, we have to prove that at least 2 points, that is 2 people, at least 2 points of G have same number of friends. So same number of friends is what? Number of friends is degree. So same degree. So in this graph we have to prove that 2 points have same degree. Now we should understand, if we take a vertex Vi, what are the possible degrees it can have? That is, we want to take a vertex Vi. So degree of Vi we want to find. What are all the possible? That is, it can be definitely greater than or equal to 0. So it can have a degree 0 if it is an isolated point. And it can also have degree 1, 2, 3, etc. Until which it can have a degree. There are totally p vertices. We are considering one vertex and we are going to find its degree. So if we have taken up one vertex out of it, how many vertices are remaining? P minus 1 vertices are remaining, and this vertex Vi can be adjacent to those P minus 1 vertices. In that case, the degree of Vi can vary from 0 to P minus 1. It can be 1, 2, 3, etc. up to, it can go until P minus 1 for each Vi. So any vertex if we take, these are all the possible degrees that it can have. So that we will just write. So I have just put that in words. Since a person can be friends with at most P minus 1 others, the degree of Vi satisfies this. Now in order to prove that 2 points of G have same degree, we are going to adopt the method of contradiction. So we are going to assume that no 2 points of G have the same degree. So the contradiction of this we will assume, and we will prove that our assumption is wrong, and therefore we will prove this. And what is the contradiction for this? We want to prove 2 points of G have same degree. Its contradiction will be no 2 points of G have same degree. So let us assume the contradiction. So let us assume that no 2 points of G have the same degree. Now we want to prove that this is wrong. Our assumption is not correct. For that, Now if no two points of G have the same degree, then each point of G should have distinct degree, and it can be integers 0 to p, because the degree of a vertex lies between 0 to p. Then what are the vertices that we have? v1, v2, etc. up to vp. Now each can have distinct integers from 0 to p minus 1. So that we will write. So then the degrees of v1, v2, v3, etc. up to vp are all distinct integers from 0, 1, 2, etc. up to p minus 1 in some order. It's not necessary all should have in the correct order. In some random orders it may change, but it will lie only from 0 to p minus 1, and each are distinct since we have assumed that no two points have same degree. But however, a point of degree p minus 1 is what? Is joined to every other point of G, and hence no point can have 0 degree, which is a contradiction. It is because if we take a vertex, one vertex will have degree p minus 1, and it is joined to every other point of G. So if it is joined to every other point of G, then how can we have a vertex with degree 0? We cannot have an isolated point in that case. So it will contradict our assumption. So therefore, our assumption that no two points of G have same degree is not correct. It's wrong. Therefore, at least 2 points of G should have same degree, so that we can have one vertex with degree 0. So hence there exist 2 points of G with equal degree, and hence at least 2 people must have exactly the same number of friends. So hence we have shown. In our next video, we will be doing a problem on an important concept. That is, we will be doing problem 3, where we will have to prove that the minimum degree is lesser than or equal to 2q by p, which is lesser than or equal to the maximum degree. So kindly follow the upcoming video lecture on this. Thank you.